Okay, we're going to be talking about this document. Okay. So, the first thing you do is you do any cancellations you can within any fractions. So, 35/60ths can be reduced. They both divide by 5, so this leaves me 7/12. Also, these x's, we're going to have some cancellations as well within the fraction. When you divide, you subtract the involved exponents. So this will cancel completely, and this will cut down to x to the 6 because 8 minus 2 leaves 6. Okay, now I think I'm going to, having finished the simplified the first fraction, I think what I'm going to do next is rewrite it more cleanly. Going to leave lots of space here to help me reduce my clutter, because these can get really cluttered. Okay, so 12 and 3, I can cancel those diagonally by dividing by 3. So 3 divided by 3 is 1, 12 divided by 3 is 4. For my x's, I can cancel these two by dividing, treating it like division. So this has the higher power, so this will cancel completely, and 10 take away 6 will leave 4, because you subtract exponents when you divide. So 10 take away 6 would leave 4. Also, these y's are going to cancel. 5 and 1. So this is going to cancel, and this is going to go down a power to 4. And for my z's, the z square will cancel entirely, and 9 take away 2 will leave 7. Okay, so I will have 7 x to the 4th over 32 y to the 4th z to the 7th. Okay, so that is the monomial. Here's monomial addition or multiplication. Here will be the monomial division. So let's see what happens when I move this. Okay, leaves me some more space. Okay, so I'm going to have example 2, 4 over 9xy to the 12th plus 11 over 10 x cubed y to the 4th z. All right, looks like I better unplug the computer. I'm liable to fall. Okay, now the LCD is got to be the lowest number. That 9 and 10 divide evenly, so that's 90. And if you're going to take all variables that appear, so that'd be x, that'd be y, and that'd be z, and you'll take the highest appearing power. That's different from greatest common factor, where you take only what appears in everything, each term exclusively, exclusive to you, it has to appear in all terms, and you take the lowest appearing power. In least common multiple, or least common denominator, you're inclusive. So you'll take every variable that has any appearance at all in the denominators, and you'll take the higher appearing power. So between 1 and 3, 3. Between 12 and 4, 12. And you're going to keep the z as is. So we're going to have, so now what we need to do is convert. So we're going to have 4 over 9xy to the 12th times, we don't know, but we know that we're going for a fraction of 90 x cubed y to the 12th z. Okay? To get from 9 to 90, we need to multiply by 10. To get from x to x cubed, we need to multiply by x squared. And to get from no z to a z, we need to multiply by z. Now, if I multiply the bottom by that, I need to multiply the top by it. Oh, I forgot the problem has z to the fifth. Okay? I didn't copy my own work right, looks like. So I would take z, so I'm going to rewind that. Okay? We're going to start over. So the LCD of this problem, because you need that for addition, least common multiple is between 9 and 10 is 90. Between x cubed and x is x, you got y, and you got z. You're going to take all the variables that appear, period. You're going to take the higher appearing power for the LCD. So between 1 and 3, we take 3. Between 12 and 4, we take 12. And between no z at all and z to the fifth, we take a z to the fifth. Okay, so now we need to convert them. So 4 over 9x squared, or 9xy to the 12th, times, we don't know that part, but we know when it's over, we're going to want a fraction that's over 90 x cubed y to the 12th z. So to multiply 9 and get 9, multiply 9 by something and get 90, we'll need to multiply by 10. To get from x to x cubed, we're going to need to multiply it by x squared. The y's don't need anything, but to get to z to the fifth, we're also going to need to multiply by z to the fifth. We're going to do it to the top as well. Okay? So that will give me 40 x squared z to the fifth. Okay, we're going to do the same thing to the other one. 11 over 10 times, 11 over 10 x cubed y to the fourth z to the fifth times, and it's going to need to be a fraction of 40 x squared, the LCD, which is 90 x cubed y to the 12th z to the fifth. Does it all fit on the screen? Yes, it does. Okay. So to get from 10 to 90, we need to multiply by 9. To get from x cubed to x cubed, we don't need to do anything. To get from y to the 4th to y to the 12th, we need to multiply by y to the 8th. And to get from z to the 5th to z to the 5th, we don't need to do anything. So 9y to the 8th. Multiply these, we get 99y to the 8th. Okay. So we're going to be adding these. Okay, so 40 x squared. So anytime you add fractions and we're adding these, you simply add the numerators over the common denominator. So 40x squared z to the fifth over the LCD plus 99 y to the eighth over the LCD is simply going to give me these two plus each other. Over my LCD, which is 90 x cubed y to the 12th z to the 5th. Okay, so that takes care of topic number 1 on that document. Topic number 2 is complex rational expressions. So I'm going to get this off the board. Topic number 2, complex rational expressions. Okay, so here's the front page of the document that we're working on. Here's the back page. Go ahead and keep the steps handy, but I'm not doing the examples that are on the paper. So example 1 we're skipping. Example 2, A. Okay, example 2A is going to be 3 over x plus 5 plus 7x over x plus 5, or sorry, x minus 2 over 2x over x plus 5 minus 6 over x minus 2. The example 2A, or example 2 on the paper, has a plus 1. And for example, and it makes the problem way longer than I want it to be, so I'm just going to remove it because you typically won't have something like that on something with a denominator, an LCD like this one. So the LCD, because these two have no common factors besides 1, is just x plus 5 and x minus 2. So we will proceed to multiply everything by it. So this one, plus 7x over x minus 2 times x plus 5, x minus 2. I'll do the same thing to the bottom. Okay? 2x over x plus 5 minus 6 over x, got to multiply it. X plus 5, x minus 2, minus 6 over x minus 2 times x plus 5, x minus 2. When this is all over, what you should have is there should be denominators that cancel, the denominators should cancel away. That's the whole point of this. Okay? So, you will have 3 times x minus 2 plus 7x times x plus 5 over 2x, x minus 2, minus 6 times x plus 5. So these are distributive property situations. Boom, 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 boom. So this is going to be 3x minus 6 so 3x minus 6 plus 7x squared plus 35x over 2x squared minus 4x minus 6x minus 30. Okay, and then for the final step is to combine the like terms on both top and bottom and put it in descending order. The 7x squared is the only one of its kind. Okay, 3x's and 35x's is 38x's, and then minus 6. Okay? Down here, we just have 2x squared minus 10x minus 30. And that's it. Okay? For comparison purposes, you can look at example 2 if you know 2 on that page, which has the additional term. But in place of that, I'm going to do another example. So example 3, which isn't on there. It's not on there. Not on paper. So we got 3 over x minus 4 plus 8 over x plus 9. Okay? So the LCD is x minus 4. So I will multiply everything by that x minus 4. 3 over x minus 4 times x minus 4 plus 8 times x minus 4 over x times x minus 4 plus 9 times x minus 4. So I multiply the least common denominator by this, by this, by this, by this. So my denominator cancels away, which is the whole point. So that will leave me 3 plus 8 x minus 4 over, well, let's go ahead and get these out of the way. X squared minus 4x plus 9x minus 36. Okay? This becomes 3, and then these distribute as 8x minus 32. Remember, you don't add and then multiply. You always multiply and then add. So distribute, and then down here, I think I'm going to go ahead and simplify this part. X squared. 4x's gain 9. If you're down 4x's and you gain 9x's, it's 5x's minus 36. And then in descending order, this combined like terms, you'll have 8x. 3 minus 32 is minus 29. And then we're going to have x squared plus 5x minus 36. And this is where I'm going to stop.